so this is our Honors Chemistry Section 8.2 lesson video, part 2 of 4. So if you watched the lesson video for part 1, then we learned the introduction to Lewis dot structures. We learned how to follow our 4 steps, and we focused on only compounds that contained single bonds and didn't have a charge and followed the octet and duet rule. So today we are going to focus on atoms that share multiple pairs of electrons, so you have more than one bond, like a double or triple bond, and we're going to cover how to do Lewis dot structures for polyatomic ions, where there's a charge associated with it. So let's go ahead and jump in, because I personally love Lewis dot structure. So a double bond occurs when 2 atoms share 2 pairs of electrons, and so a double bond is just represented as 2 dashes. So remember, we said a dash is a bond, and it is 2 electrons that are shared. So a double bond is 2 dashes because it's 4 electrons that are shared. So it's 2 for each dash. And then a triple bond occurs when 2 atoms share 3 pairs of electrons. It's represented by 3 dashes, 2 electrons per dash. So 2, 4, 6 electrons total. You shouldn't really see anything above a triple bond in here. Like, it is possible in reality, but we won't see anything above a triple bond. So if you try to do anything above that, then you need to reassess what you're doing, because you're most likely doing something wrong. So how does that change our steps? Well, when you write the Lewis dot structure, you still follow the 4 steps that we've already learned, because you're not going to really know beforehand if a compound contains a double or triple bond. You just have to figure it out as you go. So when you add up the total of electrons in your Lewis dot structure, sometimes it's not going to end up equaling step 1. Like if you notice in the first video, every time we added up, it just equaled step 1, and it was fine, and everybody was happy. Well, sometimes it doesn't. And so what you do is, for every extra electron pair you have, you need to add 1 more bond. And then you're going to need to readjust for your octet and duet rule. So I'm going to put that as a step 5, but I'm going to put a star by it, because we don't always need it. We only need it if our total is incorrect. Alright, so every 2 extra electrons equals 1 bond. And then don't forget to readjust for octet. Okay, so that's an important part. Readjust for the octet, because remember, when you're done, hydrogen needs to follow the duet rule. Everything else has to follow the octet rule when you're done with your structure. All right, so these in the beginning, these really throw some people off. Okay, so just, watch for oxygen, and then watch for CO2. I'll let you try some on the next slide. If you feel uncomfortable yet, then just watch a couple more. All right, so we're still going to start with step 1, add our valence. So oxygen's in group 16, so it has 6 valence electrons, but I'm going to multiply that by 2 because there are 2 oxygens. And so I get a total of 12 valence electrons. So step 2, I'm going to single bond. So since I just have 2 O's, obviously my only option is to bond them like this. So then we just move on to step 3. Well, oxygen follows the octet rule. So right now this oxygen has 2 electrons from the bond. So I'm going to add 6 more so that it has 8. This oxygen has 2 from the bond, so I'm going to add 6 more to give it 8. So everybody's stable. It's going just like it did in part 1, but it's about to all fall apart. So step 4 is check our total. So I have 2, 4, 6, 8, 10, 12, 14 electrons in my structure. I'm only allowed to have 12. And this is what a lot of you do. You'll just take 2 away to get it down to 12. But you can't do that, because if you look, this oxygen only has 2, 4, 6 electrons. It's not stable. So you got to follow our step 5. For every 2 extra electrons, you need another bond. So see, I have 2 extra electrons, right? Because I'm only allowed to have 12 and I have 14. So I add another bond. But then you need to readjust for the octet, and that's what some people have trouble with. They want to think, oh, okay, well, I added the bond, now I'm done. You have to make sure everything has an octet, because see, now that I've added this extra bond, they have too many electrons, so I need to take some away. So see, now this oxygen has 2, 4, 6, 8, 10. So see, I need to get rid of 2 of my dots. That's why a bond helps reduce the amount of electrons, because you can get rid of some of the dots. So now this oxygen has 2, 4, 6, 8, 10, so I get rid of some of the dots. So see, now I readjusted for my octet. So let's just make sure everybody's still stable. So see, this oxygen, it has 2, 4, 6, 8. This oxygen has 2, 4, 6, 8. So now let's recheck our total. Remember, I'm allowed to have 12. Now I have 2, 4, 6, 8, 10, 12. So they just needed to share 2 pairs of electrons instead of 1 in order to keep their valence electrons. So again, you're not going to know when you look at a formula, unless you just happen to already know or have it memorized, that it's going to contain multiple bonds until you get into drawing the Lewis dot structure. Alright, so let's look at another one together. So we have CO2, carbon dioxide. So step 1 is add our valence. So carbon's in group 14, so it has 4 valence electrons. Oxygen's in group 16, so it has 6, but I'm going to multiply it by 2. So 12 plus 4 is 16 valence electrons. Alright, so step 2 is single bond, everybody. So remember, the single atom goes in the middle. So there's only 1 carbon, so it's going to go in the middle. And so then I bond my oxygens. Alright, step 3 is follow octet and duet rule. Well, I don't have hydrogens this time, so I'm only going to follow the octet rule. Alright, so let's just start over here. So oxygen has 2 valence electrons, so it needs 6 more to get 8. Carbon has 2, 4, so it needs 4 more to get 8. And then oxygen right now has 2, so it needs 6 more to get 8. So, again, if this was our previous video and everything was single bonded, this would be perfect. But today we're talking about multiple bonds, so we're about to have it fall apart right here. So last is, of course, check my total. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I have 20 valence electrons in my picture. I'm only allowed to have 16. So again, a lot of you just do like this and take off 4, and most of y'all take it off of carbon. But if you look, now carbon only has 4 valence electrons. Remember, you can't fix it by just taking away dots. You need to add bonds, and then you can take away dots. Alright, so remember, for every 2 extra electrons, I need 1 bond. Well, I have 4 extra electrons. So that actually equals 2 bonds. Now, technically on this one, you have choices. You could put both your bonds here and make this a triple bond. You could put both your bonds here and make this a triple bond. Or you could put 1 bond on each side. Now, most molecules, when it's possible, they tend to have symmetry. So I'm going to leave it like this. However, if you had put a triple bond on one of the sides, as long as you adjust your electrons to follow the octet rule, I'll still mark that right. We'll talk about resonance structures in another section. Alright, so remember, I added my bonds, but then I need to readjust. So now I can take away some dots. Alright, so remember, we're following the octet rule. So oxygen right now has 2, 4, 6, 8, 10. So I get rid of 2. Carbon has 2, 4, 6, 8, 10, 12. So I actually need to get rid of all 4. So see, we didn't need to remove the dots, but we had to add the bonds to be able to do that. And then this oxygen has 2, 4, 6, 8, 10. So I need to get rid of 2. So let's just check the stability of everything. So oxygen has 2, 4, 6, 8, so it's good. Carbon has 2, 4, 6, 8, so it's good. Oxygen has 2, 4, 6, 8, so it's good. So now let's check our total. So remember, I'm allowed to have 16, and now I have 2, 4, 6, 8, 10, 12, 14, 16. Okay, and so again, when you are having trouble with these in class, the most common thing I notice is you don't have full octets or duets, like something's going wrong with those. So always make sure you double check. Okay, so let's see if you're ready to try some. If you're not feeling confident about trying one yet, maybe watch me do one more, but do make sure you at least try one of them on your own. Alright, so if you want to try N2 on your own, you're more than welcome to. You can pause the video. I'm going to assume you've either tried it or you're waiting on me to do it because you're not ready yet. Alright, so step 1 is add our valence. So nitrogen's in group 15, so there's 5 valence electrons. I'm going to multiply it by 2 because there are 2 nitrogens. So step 2 is single bond, everybody. Alright, and I know right now you're probably thinking, oh, well, I already know it's going to be a multiple bond. But on the test, like, there's not going to be a section that says multiple bonds. You're just going to have a Lewis dot structure section. And you just got to draw them as you go. Alright, so step 3 is octet and duet rule. So nitrogen follows the octet rule. So right now it has 2 electrons, so it needs 6 more. And this one has 2 electrons, so it needs 6 more. So see, now they both have an octet. 2, 4, 6, 8 for that one, 2, 4, 6, 8. So I go to step 4 and check my total. So I have 2, 4, 6, 8, 10, 12, 14 electrons. I'm only allowed to have 10. So remember, don't just start taking away dots. You need to add bonds first. I have 4 extra electrons, so that means I need, sorry, I miswrote a 1. I need 2 bonds. So obviously here I have no choice but to put them both in the middle. It's going to be a triple bond. But then you have to remember, now you can readjust for the octet. Okay, so if I look, N has 2, 4, 6, 8, 10, 12. So I'm going to get rid of 4. So see, now it's down to 2, 4, 6, 8. This one has 2, 4, 6, 8, 10, 12. So I get rid of 2 pairs. And so now I'm down to 2, 4, 6, 8. So see, both of them are stable. So now I can recheck my total. So remember, I'm allowed to have 10, 2, 4, 6, 8, 10. Alright, so hopefully that one either made sense or you got it right on your own, depending on if you tried it. Alright, so the next one, pause it, try it. Before you pause it, I'll tell you the order that you see them in the formula is how they're bonded. So H is bonded to C is bonded to N, like that. Okay, so pause the video, try that, make sure you remember who follows duet and who follows octet. Alright, I'll assume you've tried it and you're ready to check your answer. So hydrogen's in group 1, so it has 1 valence electron because we're doing step 1, adding our valence. Carbon's in group 14, so it has 4 valence electrons. Nitrogen's in group 15, so it has 5 valence electrons. So I have a total of 10 valence electrons to work with again. So remember, I told you the order of the bonding is just this right here. So H, C, N. So I single bonded everybody. So next step is octet and duet rule. Well, hydrogen follows the duet rule. So if I look, it does have 2. Carbon and nitrogen follow the octet rule. So carbon right now has 2, 4. So it needs 4 more to have 8. Nitrogen has 2. So it needs 6 more to have 8. Okay, so this molecule cannot have symmetry. Like some of y'all, you start trying to add dots to H just so it looks the same on both sides. You can't do that. H follows the duet rule. Not all molecules can have symmetry. If they can, they prefer it, but it's not always possible. Alright, so step 4, I check my total. So I have 2, 4, 6, 8, 10, 12, 14 valence electrons. Well, if you look, I'm only allowed to have 10. So that means I have 4 extra electrons, which means, again, I need 2 more bonds. I cannot put another bond to hydrogen. Remember, hydrogen follows the duet rule. It already has 2, so it's already full in its valence electron shell. I have to put both of them to the nitrogen. Okay, so that's very important to remember. Hydrogen can only accommodate 1 bond. So now that I've added my bonds, I need to readjust my octet. So hydrogen still has 2, which is what it wants. Carbon has 2, 4, 6, 8, 10, 12. So I need to get rid of 4. So see, now it has 2, 4, 6, 8. So carbon's good. Nitrogen has 2, 4, 6, 8, 10, 12. So again, I need to get rid of 4. And so see, now nitrogen has 2, 4, 6, 8. So I've restabilized everybody. And so last step is recheck my total. So I'm allowed to have 10. I have 2, 4, 6, 8, 10. So hopefully you got that one right. If you did get that one right, this one's super tricky because it's asymmetric, and so a lot of you struggle with those. And you have that hydrogen that you got to remember can only hold a duet. All right. So before you try the last one, remember what I told you about C2H something. Bond the 2 C's and then split the H's equally. And then don't forget when you do this one, H cannot accommodate more than a duet. Alright, so I'll assume you've tried this one and hopefully you got it right. Alright, so step 1 is add our valence. So carbon's in group 14, so it has 4. Then I'm going to multiply that by 2 since there are 2 carbons. Hydrogen's in group 1, so it has 1 valence. Then I'm going to multiply it by 4 since there are 4 of them. So we have 12 valence electrons to work with here. So again, remember what I told you about C2H something. So I'm going to bond my 2 carbons. I'm going to split the H's equally. So in this case, since I have 4 H's, they'll each get 2. And I kind of do mine out to the side, but you are more than welcome to do them up and down, you know, as long as they each have 2. So we got everybody single bonded. So next step is octet and duet. So hydrogen follows the duet rule. So this one's stable with 2, this one has 2, this one has 2, and this one has 2. And carbon follows the octet rule. So right now this one has 2, 4, 6. So it needs 2 more to make 8. This one has 2, 4, 6. So it needs 2 more to make 8. So now I can check my total. So I have 2, 4, 6, 8, 10, 12, 14 valence electrons. Wow, that's weird. I picked 3 in a row that have 14. However, I'm only allowed to have 12 valence electrons. So I have 2 extra electrons. So remember, 2 extra electrons means I need 1 extra bond. I can't put the bond to a hydrogen, so I have to put it in between the 2 carbons. Remember, hydrogen cannot accommodate more than 1. So now I need to readjust. So all my carbons are still good. All my hydrogens are still good. 2, 2, 2, 2. But now let's look at my carbons. So this carbon has 2, 4, 6, 8, 10. So I need to get rid of my dots. This carbon has 2, 4, 6, 8, 10. So I need to get rid of my dots. So everybody's stable now. So see, carbon has 2, 4, 6, 8. Carbon has 2, 4, 6, 8. I'm allowed to have 12, and now I have 2, 4, 6, 8, 10, 12. So the multiple bond ones are a little tricky because of that 5th step, but with practice, it's not that bad. For these, the more you practice, the faster you get at them. Alright, so the next thing we're going to talk about is a coordinate covalent bond. So in normal covalent bonds, each atom donates 1 electron and then they share the pair. Well, in a coordinate covalent bond, it's a bond formed when 1 atom donates both of the shared electrons. In a regular bond, like I said, each one donates 1. So like for example here, C and O, they need a 3rd bond. So O actually ends up donating both electrons to the bond. Now normally this kind of complicates the Lewis dot structure process. However, because we follow these steps, we never have to worry about this being an issue. Because if you follow the steps, it works itself out every single time. So next we're going to learn how to do a Lewis dot structure for a polyatomic ion because it has a charge, so there's some slight differences. So when writing the Lewis dot structure for a polyatomic ion, you have to take into account the charge when you add up your valence electrons in step 1. And then once you're done with the Lewis dot structure, you need to put the whole thing in brackets and put the charge. So that's the only 2 differences. Everything else is exactly like what I showed you in our steps. So let's look at a couple together. So here and for polyatomic ions, y'all, it could have multiple bonds, it could not. Like at this point, because now you know how to do single bonds and multiple bonds, anything we go through, it could or could not have multiple bonds. We just have to do it to actually see. Alright, so our first step is, of course, add our valence electrons. So Br is in group 17, so it has 7. Oxygen's in group 16, so it has 6, but I'm going to multiply it by 3. Now, it has a charge. If something has a negative charge, that means it has gained electrons. So since it's -1, it's gained 1 electron. So I add an extra electron when I'm adding them up. Okay, so that's one difference when you have a polyatomic ion. So I have 18 plus 8, pretty much. So in other words, 26 valence electrons. Alright, so step 2 is single bond, everybody. Well, I have BrO3, so we know single atom in the middle. So I'm going to put Br in the middle. Alright, so next step is octet and duet rule. Well, rule. There's no hydrogens in here, so they're all going to follow the octet rule. So this oxygen has 2, so it needs 6 more to be stable. This one has 2, so it needs 6 more to be stable. This one has 2, so it needs 6 more to be stable. And then don't forget to check on that center atom. I find that a lot. Like y'all check on the outside ones, but then you forget about the one in the middle. So Br right now, it only has 2, 4, 6. So it needs 2 more to be stable. All right, so we got everybody stable. So now let's check our total. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I'm allowed to have 26, so I don't need any multiple bonds. So the last step is I put it in brackets and put the charge, which is negative. Okay, so see there's a tiny difference in step 1 and then a tiny difference once you're done. All right, so let's look at another one together. So we have OH negative, so hydroxide. So first step is add our valence. So O is in group 16, so it has 6. H is in group 1, so it has 1. A negative 1 charge means it has gained 1 electron. So I'm going to add 1 more and get a total of 8. All right, if I had a positive charge, I would subtract that many electrons. So next step is single bond, everybody. Well, we just have O and H, so there's only one option for that. Just like that. All right, next step is octet and duet rule. Well, hydrogen follows the duet rule. So it has 2, so it's stable. So that's the thing you gotta remember is hydrogen follows the duet rule. Oxygen follows the octet rule. Right now it only has 2, so it needs 6 more to be stable. So see, now it has 2, 4, 6, 8, so it is also stable. So then I move on to step 4, check my total. Well, I have 2, 4, 6, 8. I'm allowed to have 8, so I don't need any multiple bonds. So the last step is I put it in brackets and put the charge. So polyatomic ions really aren't that bad. And like I said, they can have multiple bonds, they don't have to. Like these two don't have multiple bonds, but some on the next slide might. So if you end up with some extra electrons, you do it just like I showed you earlier in the video. Alright, so maybe pause the video and try the first one. We have PO4 with a negative 3 charge. I'll assume you've done that, and let's look at it together. So P is in group 15, so it has 5 valence electrons. O is in group 16, so it has 6 valence electrons, but I'm going to multiply that by 4, because there's 4 of them. And then a negative 3 means it has gained 3 electrons. So I'm going to add 3 more. Okay, so we have 24 right here, plus 8, which is 32. Sorry, my mental math left me there for a second. Alright, so 32. So, next step is single bond, everybody. Well, since it's PO4, P is the single atom, so P is going to go in the middle. So I'm going to set it up like this. Alright, so third step is follow the octet and duet rule. Well, none of these are hydrogens, so they're all going to follow the octet rule. So, this O has 2, so it needs 6 to make 8. This O has 2, so I add 6 to make 8. This O has 2, so I add 6 to make 8. And this O has 2, so I add 6 to make 8. And then don't forget to check on that center atom. My P has 2, 4, 6, 8. So everybody's stable. Everything's going well. Let's see if it's going to keep going well. So we got to check our total. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. I'm allowed to have 32, so I don't need any multiple bonds. So the last step is bracket it and put the charge. So hopefully you got that one right. Okay, so let's move on to the next one. So maybe try NO positive. So remember, positive means it's lost an electron. So when you add up in step 1, you're going to subtract an electron. All right, so I'll assume you paused it and tried it, and let's look at it together. So the first step is add our valence. N is in group 15, so it has 5 valence electrons. O is in group 16, so it has 6 valence electrons. A positive charge means it has lost 1 electron. So I'm going to subtract an electron, not add. So 11 minus 1 is, of course, 10. So step 2 is single bond, everybody. Well, we only have 2 elements, so obviously our only option is to do like this. All right, and so then step 3 is octet duet rule. Well, both of these follow the octet rule. So N has 2 right now, so I add 6 to give it 8. See, 2, 4, 6, 8. O has 2 right now, so I add 6 to give it 8. Alright, so next step is check my total. So I have 2, 4, 6, 8, 10, 12, 14 valence electrons. Alright, remember I'm only allowed to have 10. I can't just start erasing dots. I know that 4 extra electrons equals 2 bonds. So I obviously only have one option of where to put them because there's only one bonding area. Alright, so now I have my triple bond, but now I need to readjust for the octet. So N has 2, 4, 6, 8, 10, 12. So I need to get rid of 2 sets or 4 electrons. See, now it has 2, 4, 6, 8. This oxygen has 2, 4, 6, 8, 10, 12. So I need to get rid of 4 electrons or 2 pairs. And see, now oxygen has 2, 4, 6, 8. So everybody's stable. So now let's recheck our total. I'm allowed to have 10, 2, 4, 6, 8, 10. So we're good. So last step is we bracket it and put the charge, which this time is a positive 1. So hopefully you got that one right. If you missed that one, the next one's very similar, so it gives you another shot. Alright, so I'm going to assume you've already tried CN negative, which is cyanide. Alright, so let's first add those valence electrons. So carbon is in group 14, so it has 4 valence electrons. Nitrogen is in group 15, so it has 5 valence electrons. And a negative 1 means it has gained 1 electron, so I add 1 more. So I have a total of 10 valence electrons to work with in my cyanide polyatomic ion. So step 2 is single bond, everybody. Well, I'm going to take my C and N, single bond them. There's really no question about how to set them up. There's only 2 atoms. Step 3 is octet and duet rule. So hydrogen follows duet rule, carbon and nitrogen follow octet rule. So carbon right now has 2 from the bond, so I'm going to add 6 more to give it 8. Nitrogen has 2 from the bond, so I'm going to add 6 more to give it 8. And so then step 4 is I need to check my total. So I have 2, 4, 6, 8, 10, 12, 14. So I have 14, I'm only allowed to have 10. I have 4 extra electrons, so I need 2 more bonds. So again, I only have 1 bonding spot, so I'm going to make that into a triple bond. But then don't forget to readjust for the octet. So now carbon has 2, 4, 6, 8, 10, 12. So I need to get rid of 4 electrons or 2 pairs. So see, now it has 2, 4, 6, 8. And now nitrogen has 2, 4, 6, 8, 10, 12. So I get rid of 2 pairs or 4 electrons. And see, now nitrogen has 2, 4, 6, 8. So last step is I go back and recheck my total. So I'm allowed to have 10, 2, 4, 6, 8, 10. And so then I bracket it and put the charge. So see, that's what I meant by it was going to be similar to the previous one. Alright, and so again, polyatomic ions can have multiple bonds, or they don't have to. You just have to follow the steps to determine that. Alright, so the next thing we're going to talk about is bond dissociation energy. So the bond dissociation energy is the energy needed to break a bond. So it always takes energy to break a bond, kind of like breaking a pencil. As the number of bonds increases, the bond dissociation energy also increases. So think about if you're trying to break 1 pencil versus breaking 2 at a time or versus breaking 3 at a time. The more pencils you're trying to break at a time, the more energy it takes. And bonds work the same way. So single bonds take less energy to break than a double bond and then a triple bond. Because of course, for a triple bond, you're breaking 3 bonds at once. Now, every type of bond, depending on what elements it has its own bond enthalpy, which is the energy required to break a bond. And so we'll look at some of those a little later in the chapter. Alright, and then bond length. The distance between the nuclei of the atoms involved in a bond is called the bond length for the bond. As a general rule, the distance between the bonded atoms decreases as the number of shared electrons increases. So if you look, here they're just sharing 1 bond, and so it's about 153 picometer distance between the 2 carbons. Here, they have a double bond. They're sharing 2 bonds, And so now it's only 134 picometers. And then here, now that you have a triple bond, it's only 120 picometers. So the thing is about those bonds is the more bonds they have, the closer it holds those two atoms together. So our bond length decreases as the number of bonds increases. So we'll stop here for this video, but just keep in mind this section still has 2 more videos. So please make sure you watch all 4 parts so you can fully understand how Lewis dot structure works.